So we're going to start first with use of imagery in GIS. Why do people want to use it? Most of you probably know this. Hopefully that little portion helps you talk to other people when they say, well, why are you using imagery? Why is that so important? We'll talk about the sources that come with the platform. Then we'll go through the information model, and finally we'll talk about the exploitation and processing side and dissemination side of imagery within ArcGIS. So first of all, I always like to say if I can see it, I can understand it. And I think a lot of our users think that way. Traditional GIS data is kind of thin, right? I'll use an example, which is a real life example. I was asked by a friend to look at his farm. He says, I just bought a farm and it's really interesting. I think you should go take a look at it. So of course, first thing I do is I open up a base map. It's got roads on it, and this is what I see for his farm. It's not very rewarding, right? So I said, I'll turn on the topo base map, and I get this. And okay, so I kind of get an idea that he's got a nice long driveway, a few buildings. There's a little bit of hills there. I can see there's some sort of vegetation, but I don't know what it is. And so, of course, the next reaction is step it up one more level. Let's go to a base map. And when you turn on the base map, of course, you get a much richer understanding of what that farm is like. You can see he's got a swimming pool. Oh, I see. He's got horses because he's got a dressage ring, so on and so forth. So this is a very traditional way for people to use imagery within the stack. And we want to talk about where that imagery comes from, how that gets built, what are the options that you have. So imagery, first of all, is very timely, right? It captures things for a moment in time. And a moment, or actually a day before this image was taken, your terrain was very different. Your GIS data was really very different. Imagery is sometimes used in that way to help bring you up to date, so to speak, and explain situations very clearly in terms of what happened. In this case, a tornado hit. But we also have to remember imagery is very metric, right? It's geometric. We all kind of get that. Yeah, we have the mensuration tools in the image analysis window. We can go there and we can measure the heights of things. We can measure sizes. But it's also radiometric. And the radiometric character of imagery is really what a lot of the technology stack is designed to provide to you through image services, through Mosaic Datasets, or just through direct file access to the imagery. And there are tools in the stack. We're not going to talk about them today, but there are tools in the stack for exploitation. You can segment images. You can classify images. You can reach to other packages like our partner packages. Envy is a good example where you can add more tools into that toolbox and deal with things in a radiometric sense. Okay, let's start with sources. Imagery base maps, I mentioned those. You do get a worldwide imagery base map with ArcGIS. And most often it's used only as a base map, right? People look at it. It still brings a lot of value, but base maps aren't something that you use as analytical surfaces or analytic services. So they are stored in a data structure. They're typically stored in a tiled cache, which means that if they started out as a 4-band image or let's say a 11 or 12-bit image, that's all compressed down to a 3-band 8-bit image. And so you lose a lot of the value of the imagery, and hence you don't exploit this imagery. You basically use it as a base map. There's also a timeliness issue with these base maps. They're often a year or more old, and that's pretty common across the industry. The good news, though, is they're free to the user, and it's what you find online free. It's just that you can't analyze with them. ArcGIS Online base map varies anywhere from 0.15 meters, that's a nice way of saying 6-inch ground sample distance, up to 1 meter or 3 feet for a single pixel. Good for examining man-made features, but again, the timeliness is a 1 to 3 year time frame. There are analytical sources. They're primarily used to extract feature data. They're used for remote sensing purposes. What you'll find is they aren't necessarily all color imagery or even multispectral. They might be radar, they might be thermal, and they come from various platforms. They too are stored in a data structure, but one that allows you to get at the raw pixels, and we're going to talk about how that works. They vary in cost. Very rarely are they free, right? So depending on what your need is, somebody's paying for this, and probably it's a premium capability. But they are analytical in nature, and people use them for classification of features, feature extraction, change detection. There are 3 of those which come with the product. They're complementary. First one is Landsat Global Land Survey. Now this is a collection of epic data beginning at the earliest images of Landsat, so they go back roughly to 1975, then 1980, then 1990, 2000, 2005, and 2010. And what those are collections of images that provide a uniform coverage of the Earth. They're the best image near that epoch, near midsummer. Now, if they can't find one that's cloud-free or best image quality, they may jump a year. So you might, for a 1990 epoch, you might find one in a handful in 1989, a handful in 91. But they're generally geared around these 5 or 10-year epochs. And they are analytical in nature. You get full access to the raw pixels if you wish. We've also stood up a Landsat 8 service. Landsat 8 service gives you the best, latest 5 images worldwide. So if you take San Diego, for instance, you look at it, there'll be 5 images there. There'll be the most recent, best images of San Diego, meaning that they'll be cloud-free, good image quality, so on and so forth. As a new image occurs, maybe one gets taken last night, it will show up today and it will bump one of those older ones out of the way so that we have 5 available. We also, and just like the GLS services, those are available for analysis. We also provide NAPE imagery, which is good for the continental U.S. 4-band data, 1 meter, we get that direct from USGS, and those 2 are fully available in terms of their radiometry, so you can in fact exploit those. So the platform integrates all types of images, multispectral, panchromatic, thermal radar. We don't think of LiDAR normally as imagery, but it is remotely sensed data. You can handle LiDAR data, and of course there is a complementary plugin. If you use full motion video with MISB metadata, you can exploit that within the product as well. We're not going to talk about that in this session, but that is available. Once you get the product to accept the imagery in, you store it, you can access it, then you have a wide range of tools available for things like color balancing, mosaicing, building those base maps, if you will, but also for things like image classification, feature extraction. There are alignment tools, and there's also mensuration tools. Okay. I'm not going to give a demo of this in the interest of time. I'm going to move forward, and we're going to hand it over to Mike, and he'll pick up on the information model.
Seamless. All right, like Jerry said earlier, one of the things that we're going to try to do in this session is to teach you what a conversation might be like in the halls of Esri Development in Redlands when we talk about imagery, right? And the reason behind that is because when you read our documentation and when you look at blogs and when you try to figure out how to use our system, it's really hard to understand if you don't understand the concepts and the terminology and the way that we actually think about the platform. So the best way to do that is to go through the important aspects of the information model. Okay? So let's just dive in. And step 1 is to really understand how we're thinking before we even decide on what these terms are. And that's about our underlying design principles, right? So the first thing that you'll notice, you hear us talk a lot about only process what you need. We're dynamically processing imagery on the fly, and you hear all these terms. Well, it comes from this notion that we believe that the primary use case for processing imagery, when possible, is to only process what you need. which is don't take your 100,000 images, run them through a pipeline to create 100,000 new images of NDVI if you don't have to, if you're never looking at all of them. So why do that? It costs you extra storage. It costs you all this extra processing time. So why do it, right? So for us, we first try to approach the problem in terms of only process what you need. The next is imagery is unique and different from vector data in the sense that how many of you actually look at metadata of vector data? Okay, we got less than 5 hands, right? So vector data tends not to be as relevant, metadata in vector data tends not to be as relevant as imagery. In imagery, you have to have it. To make really good use of imagery, the metadata is key. So we care a lot about the metadata. We want to look at everything that's in there and make sure that the tools understand the metadata so that they can do the things they need to do better. Next up, the third actually goes along with the first, which is, you know, if we're only processing what we need, we want to optimize storage, right? Because one of the big issues with imagery is it can easily it goes from gigabytes to terabytes to petabytes extremely fast. The other thing is people like to keep imagery around for historical purposes. So your library continues to grow and grow and grow and grow and grow. So we care about storage. We only want to use storage when we absolutely have to. And finally, you know, one of the value adds we try to bring to the table is we're a GIS data management company, which also means we want to be an image data management company. So managing large collections of imagery is always in our mind when we talk about, when we start to do design work in the software. It doesn't mean we don't think about single scenes and single scene processing. It just means that we want to make sure that it's also going to work in massive image libraries. Okay? Next up is, you know, now that we're thinking about this, what are the actual principles that we base our development on? And why is the model the way it is? Well, it's based on these key principles, which is we always have an information model. And an information model is both the data model and the business logic that goes along with it, right? We store things in a geodatabase. I'm sure you've heard that this week. You've probably heard the term geodatabase, right? So we leverage a geodatabase. What this really brings to the table is this notion that we can build an information model that works for all of our products across the platform. So that means if we design an information model that works in ArcMap, but you couldn't use it on a mobile device, someone doesn't like that. If you design an information model that works in ArcMap but doesn't work in Pro and doesn't work in Server, that's a bad information model. So in terms of whenever you talk to Esri folks, you'll find out that the information model is a really important part. So when you understand the information model, you understand a lot about the ArcGIS platform. Okay, so now let's get into what it actually is for imagery. There are really, 6 key terms. If you were to walk away from this session with the minimum amount of writing down on a piece of paper, the things you need to go look at later, it's those 6 things in yellow, right? Because those 6 terms are the foundation of our system when it comes to imagery. They are the key pieces of the information model, right? First is Raster Dataset. Next up is Raster Type. Then we have a Raster Function. We have a Raster Product, Mosaic Dataset, and an image service, okay? So if you talk to an Esri person, they're going to speak this. They're going to say, what kind of, are you using Raster types? And if you don't know what a Raster type is, you're like, oh, I don't know. I'm using a World View 3 scene. Is that a Raster type? I don't know, right? So it's important that we teach you this, okay? So we're going to go through each one of these, and I'm going to try to do a very concise, small demonstration so that you see where they sort of fit into at least the ArcMap view of the world. So the first one is Raster Dataset. You can think of Raster Dataset as the most primitive part of the information model. Think of it as the format drivers. Think of it as a basic image, which is if I have a TIFF on my disk, I would call that a raster dataset. Okay? Now, one thing I always tell people is, at Esri, because of our roots in GIS, we say raster. Right? You can actually replace that word with image. You could say it's an image data set, right? But Esri will talk about it as a raster data set. But in your mind, it applies to imagery, okay? So this is really simple. It's a really simple concept. You know, we have over 80 formats supported of basic raster data sets. It involves all the notions of pyramids and basic metadata. It can be multi-band. It can be, you know, any type of storage, 11-bit, you know, 8-bit, whatnot. So it's really about, this piece of information model is really about just the lowest level component that's used to read the pixels and the metadata. So from the most simplistic standpoint in ArcMap, that's essentially, I have an image, it's on my disk. That little icon over there that looks like a yellow grid is a raster data set. It's just a TIFF, and I can drag it into ArcMap, and that's my raster data set. Okay? That's the first step of understanding, right? Very basic. Okay? But we're going to build on this. And you'll start to see how it all fits together. So we'll close that, and we'll go back, and we'll move to the next part. So next up, it starts to get into what Jerry might define as getting a little bit more intermediate, right? So if you're just working with TIFF files and it's all your, you know, you're just working with single ones in ArcMap, raster data set is your home, and that's what you know. But to do the really cool stuff, we have to start understanding some other things. So next up is a raster type. And what is a raster type? A raster type is essentially a piece of intelligence in the information model that's designed specifically for one sensor. Okay? So think of a raster type as the brain for Worldview 3 imagery, the brain for Terrasat, the brain for Landsat 8, right? So a raster type is the component, it's the part of the information model that's very sensor specific, and it's smart enough to go in and dig into that specific metadata and come up with a bunch of business logic that's relevant for that sensor, right? Because the business logic for a radar image is different from the business logic for a multispectral image, okay? So in ArcGIS, there's over 40 of them today. Some examples are down there, like, you know, we have Landsat 8, we have NITIF, we have CIB, DMCII, DTED, Formasat. So you can see Worldview, Spot, and you can see that they're very specific, okay? And we can take a look at those to better describe that. So if we do a quick demo of what that type is, right here. So I have, the best way to do this is to show you the user experience and how it changes for each raster type, okay? So what I'm going to do is I'll bring up the Add Raster tool for Mosaic Datasets, which we'll get into later, but this is the easiest place to see it. So in this particular GP tool, you can see this is where all the raster types are, and that's the list. Now what's interesting is, and really drives home this notion that they're very specific, is that, let's say for example I pick QuickBird and look at the property sheet for a QuickBird raster type. You'll notice that it reads the metadata and says, I understand the wavelengths for QuickBird are this, so I know how to work with different bands. It understands that it can automatically build some processing templates, right? It understands that when crawling the disk, I look for these types of files to ingest it. And it also knows how to build up what we'll talk about next is processing chains to dynamically process the imagery. Okay, now if we were to take and look at a different raster type, so let's say for example I'll pick RadarSat and I'll look at its property sheet, you'll notice that it's showing polarizations. Right? So it's very specific to the sensor. Okay? So it's basically allowing you, every time you bring up a type, it's going to have a different set of configuration and a different set of defaults for working with the imagery, right? So think of it as really smart metadata readers that formulate software business logic when you're working with that type in the system. Now, the raster type is really, it's a terminology that you need to know in terms of, if I'm working with Worldview 3, I should know that when building Mosaic Dataset, I should pick a Worldview 3 raster type because it's going to be a better Mosaic Dataset because it's going to be really smart. Okay? That's the level you need to understand. You don't really need to understand it at what does every type do. You just need to know, what do I have? What type should I be picking? All right. So here's where it gets really interesting. So the raster types can take all that smarts they get from reading the metadata, and they can start to build up processing. And the building blocks behind processing are raster functions. So you'll hear this term, raster functions. The term that you hear on the plenary, and you might hear, excuse me, on the island, is on-the-fly processing, right? Well, on-the-fly processing is all built using raster functions, which are chained together. So what is a raster function? It's the primary component responsible for processing pixel data, right? They can be geometric, they can be radiometric, which is they can do an orthorectify versus doing a bandmath, right? They take a chunk of pixels from an image as input, they do something to it, and they hand out a new one. And then the next function takes that result, does something to it, processes a new one. And in most cases, it's all happening in memory. That's why you hear the term on the fly. So you take single ones, there's over 50 of them, and you combine them together into a model, which is a function chain. And then it just executes every time you make a request on the service or on the image. And it pipes the pixels through the chain before outputting them to the screen or outputting them to disk if you want to create a persistence representation. So it kind of looks like this in its simple form, which is I have a really big image. The function is fed pixel blocks. The pixel blocks go into the functions. They do something to the block, and they either go straight to the screen or they go to another function or they go out to a cache or a new image or persistent result, right? So basically, zinging through the system, and this block of memory just keeps getting modified through the system until it ends up going someplace, right? So it's a piece of your image. So let's quickly go over this before I do the demo, which is one of the places of confusion that always happens is what's the difference between geoprocessing and raster function chains? And when should I use one and when should I not use the other? So there's some simple guidelines behind that, which is, first and foremost, if Esri didn't implement a function for you to do your job, you can't really use raster functions. If there's a missing GP tool, but there is a function, okay, so those two examples are pretty obvious. But there's a little bit more to it, which is, with geoprocessing models, I can integrate vector data into my image processing, right? So if you have a bunch of vector processing and then you want to raster to vector, vector to raster, and then do some more in geoprocessing, then you're going to want to go with GP, right? Second of all, if you have a heavy requirement to control the environment that the GP environment provides, you'll want to use GP as well. There are also a set of algorithms that are more suited to geoprocessing because geoprocessing can process global in the sense of the algorithm can be global, which is work on the entire image at once. Whereas raster functions have to be localized. They have to be kernel-based operations or local, right? So some algorithms can't be done per block. They have to look at the whole image. Cost distance in GIS is a good example of that. You can't just do cost distance per pixel block, right? One of the guidelines we like to say is that if you can do it with raster functions, you should do it with raster functions. And the reason behind that is it's fast. You're only processing what you get when you're visualizing. They make much more sense in terms of a web interface eventually. So let's take a look at a demo. And hopefully this sort of drives home the concept. So I'm going to sit down for this one. And let's see, the first thing we'll do, I have a little simple example here, is I have an image, a raster dataset, and I have a shapefile of a study area, and all I really want to do is compute NDVI, but I don't really need to save the result because I just want to look at it, and I only want to process my study area. So I don't want to run a GPU tool against the whole process. I actually just want to do the study area. So what can I do? Well, here's where raster functions come in. So if you haven't seen it before, ArcMap has this image analysis window, which is pretty cool. It sort of houses all of the quick and easy display tools for imagery. And it also provides a way to start building some of this on-the-fly processing for an image. So what I'll do is I'll select my image. Then what I'll do is there's this button down here that says FX, function, add function. So what I'm going to do is I'm going to start that out, and it's going to bring up the user experience for defining my processing, which is editing my function chain. Okay? So the first thing I need to do before I do NDVI, I said I only want to process the area. And I mentioned before that functions can be radiometric or geometric. So the first thing I'm going to do is I'm going to clip. So I'm going to clip my image dynamically on the fly to the shapefile. And I'm going to say OK. And I can turn off the original image. I'll change my bands back so it makes more sense. And there I go. So now my image is clipped only for display on the fly. And the resultant image in the chain so far is basically said we're not going to be using any of these other pixels. So any further processing is only going to process those pixels. And I said I wanted to do NDVI. So now that I have that, I can actually open that up again. I can find my clip function, say what did I want to do after clip? I wanted to run NDVI. So what I can do is insert NDVI and make sure I have my infrared band. I hit OK. Oh, now I have an NDVI result, but it's grayscale. So let's apply an on-the-fly color map of that. So I'll go back, edit it again, and add a color map function. And I'll pick the handy-dandy NDVI. And so now I built up this function that from disk, read the TIFF, read the pixels, but only take blocks of those pixels, pass it through the clip function, pass it through NDVI, now pass it into color map rendering, and be done with it. Okay? And as I zoom around now, I'm only processing those pixels. Okay?
So one good rule of thumb here is when you're building a raster function chain, you want, if it's for display purposes, you want to keep the total timeline for that to about 750 milliseconds, right? Because then the user doesn't realize that all that processing is taking place. If your function chain gets out to 3, 4, 5 seconds long, it's not responsive and hence doesn't work real well.
Okay, did that make sense? Okay. So now we have raster datasets, which are reading the pixels in the metadata. We have raster types, which are really smart about what to do with it once they get it. And now we have functions that can be fed pixel blocks for processing. Yeah. Which function? The definition of the function? In that case, what I showed you was applying a function chain to a layer. Okay? That's actually happening. If you save the map document, it stays that way. Okay? Create a tool. No. No. So they're not tools, right? They're executed on the fly. They don't go into a model. They just execute on the image. Now, I think what you're getting at though is how do I take that and apply that to many images, right? And that's done through the Mosaic Dataset. So we'll get to that, okay?
Yeah, so they do, I think there's a related question here too.
Yeah, they persist, but not in the information model part we talked about yet.
Right.
They do persist. Yeah.
You can persist them in Mosaic datasets or raster function templates. And then the model, or the raster function chain will persist on, so the definition is there. But if you choose to take the result of that, you can also persist that into a new image if you want.
Yes. So you can always save the image out after you run the function. So if I were to bring up the copy raster GP tool on that layer, I would end up with a little NDVI clipped image as a new TIFF file on my disk as well if I wanted to save the result, right? So, but I think the bigger point you're getting at is what we'll get at with the Mosaic Dataset, which is going beyond the single image into how do I do some batch processing and mosaicing, right? So next up is we have this notion in the information model called a raster product. And a raster product is really there to help you. And what it does is it says, I know that the raster types are available to me and can provide me with some certain information. I know that the raster datasets are there for providing pixels and metadata. And I know that these types are specific. So the raster product is, what can I represent to the user that's intelligent that they don't have to worry about because I have all this intelligence behind me? And that's really what the raster product is. And they appear to you as shortcuts in the catalog window, which is easier ways to work with complex image deliverables. So if you're given a WorldView 3 scenes, you get lots of files. And if you try to, pick out which TIFF files are red and green and which ones are combinations and whatever, and put them all together yourself, well, why do you have to learn to do that, right? We have all this intelligence. So the easiest way to see that is to do a demo again. So let's take a look at a raster product. So if I bring up the catalog window, and I'm going to open my Mosaic map document because I have some bookmarks. And what you're going to notice is when we talked about raster dataset, you saw the little green or little yellow gridded icon, and there's some there for the TIFFs. But you also notice there's this special little icon there. And that special little icon is representing the raster products that can be created from this type of imagery because it's really smart. And it has a little sensor on it. So in this case, I can expand it, and it tells me, that particular image can easily show you the multispectral view, the panchromatic view. Oh, but yet, what's really cool is it can show you pan sharpening on the fly automatically. So you don't have to run a pan sharpening; it'll just give it to you right away. And the way it does that is because it says, this raster type's really smart. It has all this processing. I can build up a function chain to pan sharpen on the fly and show it to you. Okay? So if we look at it, it's easy to work with. I say, I'm going to look at my multispectral. Oh, that's cool. That's my image. But, I zoom in, and it's a little fuzzy. It's multispectral. I know the panchromatic is higher res. So maybe I want to look at the panchromatic. Oh, that's really cool. I think what I'll do is actually zoom to the resolution of the panchromatic. Now it's crisp, but it's not color. And I really want to look at it in color. Well, how about we just bring in the pan sharpen on the fly? So now I basically see the pan sharpen result dynamically. I didn't have to create a pan sharpen TIFF. Right? So if you were to look at this, remember we talked about with function chains. So if you were to look at this layer, that the product built for you, it built up the dynamic chain for you. So it said, oh, you have the multispectral TIFF file, you have the pan-TIFF file. We're going to orthorectify it. We'll run a quick convolution on it to make it look good in terms of pan sharpening. I'll add in a pan sharpening dynamic function, stretch it out for you, put it on the screen. That's the intelligence that came with having the raster type. Right? So this visualization now is executing that chain for pan sharpening every time you pan and zoom for only the blocks that are appearing on the screen. That becomes really useful when you think about how we turn, when you think about turning all this into image services, because as you're panning and zooming on a browser, you're only processing ever the size of the screen. Okay? So that is raster products. So let me just reset this so when we come back, let's get back to our presentation. Okay. So all of those concepts are sort of, they come to fruition in this next piece of the model, which is really the Mosaic Dataset, right? The Mosaic Dataset is really the centerpiece of the information model for how we work with imagery. And that's because it takes all of this, all the pieces in front of it, and combines it into a concept of applying that concept to large collections of imagery. So rather than working with a single TIFF on your disk, you can actually ingest millions of images, design out your end user product, and apply all this dynamic processing to it to deliver that product either through an enterprise application, through ArcMap, or through SDKs, or through web services.
Probably one word of caution, though, is don't think of this as a mosaic, right? There's no mosaic like you get from a vendor. And it's not really a data set, it's more of a catalog. So.
The reason behind it being called a Mosaic Dataset is because one of the primary features it provides is dynamic mosaicing, right? It allows you to actually mosaic many images together. Now, that doesn't mean that your view of the Mosaic Dataset always has to be a mosaic. Many people use it as just a pure image library for working with single scenes. Okay? So in terms of talking about it, it's when the Mosaic crawls a folder to add imagery, it uses the raster types and gets really smart stuff and builds up a really smart set of records inside the geodatabase. It talks about, it knows everything about all those images you put in it. Builds up chains inside. Then, I think the interesting part about it is just talk about scalability. So you can use it for 2 images. I mean, you could use it for 1, but I don't know why. But you could use it for 2. And we have users that actually have 25 million in one mosaic. Now, those are mosaics that are multi-product, multi-scale, which is they have a high-resolution pan, and they have some multispectral, then they have some Landsat, and they put it all in one big thing so that as the user is going in, they're seeing different data. So there are use cases where people have built these really massive mosaics so that they can use different sources at different scales. But just to give you a sense, and that points out the other bullet that's on here, which is you can design a Mosaic data set to have one source, which is it's only a Worldview 3 Mosaic data set. That's all that's in it. Or you can say, I'm going to put some Landsat, I'm going to put some of my own TIFFs, and I'm going to put some aerial in it. I'm good, right? So they can be mixed sensor, or they can be a single sensor. Okay? All right. So let's go ahead and do let's do a demo of the Mosaic data set. How are we doing on time?
We're doing good.
Okay.
10 after 2.
10 after 2. All right. So let's do a demo of the Mosaic data set. And what I'm going to do here is go through this with you real quick on how to create one if you haven't created one. So the first thing is I'm in a folder. I'm going to say new. I'm going to say file geodatabase. And I'm going to say raster intro. going to be my geodatabase. I'm going to right-click the geodatabase. I'm going to say New. I'm going to say Mosaic Dataset. And because Mosaic Dataset wants to create you a product, it's a library, so let's give it a name. So we'll call it Raster Intralib, just for fun. Then we have to pick a coordinate system. And depending upon where your data is, for me, I'm going to just make it WGS84 so I know that everything fits. But you can have any coordinate system in ArcGIS. So if you're only working with UTM Landsat, you can just pick a local coordinate system if you want. Okay, but we're going to pick WGS84. Now, if I know that I'm only using a certain sensor like WorldView 3 or QuickBird, I can pick a product and say, I know I'm going to only put QuickBird 4-band in here. And if you do that, the Mosaic Dataset will be really smart to start with because it'll know how to map everything to RGB and infrared. Okay? In my case, I'm not going to do that. But that's just to let you know, read up on this part because if you are using only one sensor, you'll want to use a raster product. Okay? So then I just hit OK. I take the rest defaults. It goes really fast. It creates a bunch of stuff inside the geodatabase to ingest and record what kind of imagery I'm adding to it. Now I have, if I expand my geodatabase, there's our Mosaic Dataset. Now what I need to do is add imagery to it. And because we talked about the fact that, exchange the word imagery and raster, it's going to be called add raster. So let's go ahead and say add, right-click it, say add rasters. And we talked about raster types. So I'm going to put QuickBird in mine. So I'm going to pick a raster type, which is QuickBird. I'm going to configure because I only want multispectral. Whoops. So I'm going to go to General, and I'm going to say, look, I only want, you can give me all these products automatically, but I'm actually only going to do multispectral because I'm going to show you how to do NDVI on more than one image as a result. So basically on the fly, multiple images, right? So I'll basically pick multispectral, okay? I'm going to click OK. Now I have to pick a folder I want it to crawl. Where's my data? Oh, here it is. Okay, so here's my data. And that looks pretty good. So let's just run it with the rest of the defaults. Okay, so if you look at what the dialog says, it says, I crawled a bunch of data, I added some stuff, I synchronized, I knew the type was QuickBird, and I updated some information about the mosaic. Okay, so looks pretty good.
So the important thing is we didn't move any of the imagery.
We didn't move any of the imagery, and when we say we ingest the imagery, we don't copy it. It's like saying we read a bunch of information about all those images, we stored a little bit of information in the geodatabase, but we did not copy the imagery. So we're only referencing the imagery stays where it is, right? Back to the design principles we talked about earlier, which is we don't want to use storage when we don't have to. So this is purely referencing the imagery. So we zoom to the layer, and now you'll see that I see two of my images, but two don't show up. Now, a lot of people run into this. They're kind of confused about why did that happen. Well, it happens because there's some fail-safe mechanisms built into the mosaic, which is if I ingest 50,000 images, I don't want to be drawing 50,000 images on the screen, right? So the images are there, okay? So I'll give you an example. So if we zoom in, you're going to see them all draw, okay? So there's some fail-safes. Now, those are all configurable. You could right-click the mosaic in the catalog and go to its properties and change how many images draw, how many pixels draw, all that kind of stuff. But so if you try this and you're not seeing all your images, don't be confused that they didn't get into the mosaic. Just take a look at the documentation about some of the fail-safes that are in there to keep you from doing the wrong thing. So now I have this no data problem. Right, my mosaic doesn't really look that good because I have, no data. So let's fix that. So what I can do is I can right-click the mosaic data set. I can say modify. I'm going to say define the no data. I'm going to say wherever all the bands and any of the images are zeros, please turn it into no data. I run that real quick, and now you see I have a nice mosaic. Okay, so that takes care of that part. That's just sort of cleaning them. cleaning up my mosaic a little bit. Okay. Now, because these images are multispectral, and I want to do NDVI, I need a way to normalize them all. So I'm actually going to apply an apparent reflectance on all the images. So, and that gives me top of atmosphere.
Mm-hmm.
Right?
Radiance.
Yes. So I'm going to select these 4 images. And now this is a way that you can modify the chain for every image in the mosaic. Okay? We saw how we did it with one. We actually have a batch tool to do it for many that you select. So I'm going to say batch edit, and I'm going to say insert a new function into the chain. I'm going to search for the existing chain to find out what's there, because I know that I have to do this after I'm going to do this after the ortho rectification, which is the geometric function. So I selected geometric, and then I'm going to, same user experience, I'm going to insert a function called apparent reflectance. Okay, and then I'm going to say next. It's going to say it's going to update 4 images, 1, 2, 3, 4. It does that. I don't see anything. Well, why don't I see anything? Well, because I forgot to remove the stretching. Okay, so I'm going to do it again. This time I'm going to say edit. Oops, back. I'm going to say remove. I'm going to search. I'm going to remove the stretch function. Okay, now we have, it's dark, but it's normalized, right? So what I can do now is the same thing I showed you before. One thing I'll show you just before we do the NDVI is, you see me keep clicking on this footprint table. Well, the footprint table represents the footprint of every image that's in your mosaic. It's a way that the records are managed. So you can right-click it and open up the attribute table, and you can see that that's really part of the information model of the Mosaic Dataset, right? There's a bunch of rows in the geodatabase and a table that define all the imagery. It also defines all the processing. So I showed you how to do it batch. If you wanted to do an individual image, what you would do is select an individual, and you get the same user experience. So you can actually apply different processing to different imagery if you want to. Okay? So in the sake of time, now I can do the same thing I showed you with single image, which is I'm going to go over to my my mosaic, and I'm going to hit the NDVI button, and voila. Okay? So now I have, if I zoom out, right, I'm not going to see them because of my restrictions, but no matter where I zoom on the fly, it's going to generate NDVI. And it's going to mosaic them all together. Right? So that's why that Mosaic Dataset concept becomes so important. And that's why everything we talked about before the Mosaic Dataset, you can see are building blocks to make the Mosaic Dataset really powerful. Because not only is it 4 images, you can scale that up to thousands and hundreds of thousands and millions. So a good example is the way that Esri builds the world imagery base map for online is by using Mosaic datasets and putting a whole bunch of imagery in it and processing it all and then cutting it to tiles. Because that's what base maps are, is tile services. Okay? Now, that's really great if I'm on desktop, and that's really great if I'm in the enterprise. But we all like to think about what it means for the web, because we have a lot of field work and we have a lot of use cases for the web. And that's where the final piece of the information model really comes in. And that is called the image service. Now, I'm not going to answer the question why that's called raster service, because we use raster all the way. But it's called image service. It's the primary way, the easiest way to think about it is take an image or a Mosaic data set and web enable it. That's it. Okay? You want an image represented as a web service, or you want a Mosaic dataset represented as an image service. So image services are really to provide imagery as a service. The distinction between, keep in mind, the distinction between imagery as a service and a Bing map and a Google map in an Esri base map is that those are tiles and image service is not tiles. An image service can serve out everything. If you have 8-band imagery, it can serve out all 8 bands over REST API. It's not a picture. It can give you a picture, but it can serve out data for analysis. It can serve out the metadata records. So it can give you a full-blown representation of a native hierarchical metadata over REST API. Okay? So they're very advanced. They can do everything, not just pictures. They also allow you to use it as a way to construct an image library for providing applications like clip, zip, and ship, and download a single image. So they can be the way that you disseminate individual images, or they can be the way that you disseminate everything about all my images. And we're not going to demo that today, actually. Now, the big part of this is putting it all together to give you a better picture of what we just saw, especially in my demo. So basically, you have this collection of imagery that comes from the sensor, goes to a ground station, or gets flown down to the ground and gets taken off the bird. You have this whole big collection of imagery in its native form, right? You combine that with ingesting that imagery into Mosaic Dataset by leveraging the Raster types. The Mosaic Dataset points back to the imagery. It doesn't copy it. You author your set of processing that you want using Raster functions. Meanwhile, your users who might use your Mosaic Dataset might be using Raster products in their applications. And they use that via desktop. They can directly use the Mosaic like you saw me do. Or they can combine that with ArcGIS Server and web enable the Mosaic Dataset as an image service to provide everything that the imagery provides to all the clients, whether that be desktop, mobile, or web. Okay? So, we're going to go back to Jerry. So 6 key pieces. So the thing that I ask is, more than anything, is if you're going to go online and search for help, try to use those terms. If you're going to talk on GeoNet, or if you're going to talk to an Esri tech support person, always try to use those terms. People will get straight to the point. They'll know what you're talking about. It's the way Esri talks in the hallways. So, very good.
Okay, let's kind of take a step back. Talk about what are my choices when I work with imagery. So, a lot of people work with imagery one file at a time. Absolutely can do that within the product. If you're in ArcMap, you're in Pro, you can definitely work with one image at a time. But you can also work with collections at a time. Mosaic datasets behave in such a way that a collection of images acts like one object or one layer. And so the Mosaic Dataset allows you to pull multiple images together and work with multiple images at a time, almost as if they were one file. That's true if I'm on a desktop connected to a network area storage or something like that. However, I can also turn those into image services. If I turn them into image services, they can be anywhere on my network. And again, they behave just like the Mosaic Dataset, in some cases just like a single file. So if I'm in one of our applications and I'm tied to an image service, I really don't care where that image is coming from. It's going to have a very similar behavior as if it were on my immediate machine being pointed to with a Mosaic Dataset. In some cases, it can behave and hand me an image at a time right across an image service. That's all enabled by the technology we just talked about. Okay, the processing side. Traditionally, I want to create new images. Well, with on-the-fly processing, I'm able to create dynamic virtual images, right? So that's what the Raster Product allows you to do, but it's also what the image service allows you to do as well, and for that matter, the Mosaic Dataset. So to the user, these things look like they exist. In reality, they only exist when I make that screen request or that block request, and it processes it on the fly and then hands me the resultant image. We refer to that as a virtual product. Now, maybe I want to persist all these things, and maybe I want to tile them all up. Well, I can actually use the same technology to create a tiled cache. Bundle it all up, build a tiled cache, flatten it out in terms of its data, make it very fast. If all people are going to do is use it as a backdrop, that's a very appropriate thing to do. We talked very little bit about geoprocessing tools. There's almost 100 processing tools in the GP framework for image management, image processing. We also talked about and contrasted that with raster functions, which handle on-the-fly processing. So, on the exploitation side, take advantage of the ready-to-use imagery if you need to or can. In the case of ArcGIS Online, we talked about what those were: base maps, Landsat GLS, Landsat 8, and APE. There's also premium services, such as the Hexagon data set or Airbus data set. So premium services exist in the marketplace as well. But depending on what organization you belong to, there may be premium, the equivalent of premium or other services available to you as well. You can use it to visualize images, but you can also use it to extract information from the imagery. We didn't get into image classification workflows today, but those are available. Oh, guess what? They work on an individual file. They work against a Mosaic Dataset. They'll work against an image service as well. And, of course, last of all, there's measurements. Mike had the image analysis window up. There's a panel on there for mensuration or image measurements where you can do geometric interactive measurements on images as well. Now, at 10.3, we introduced a new coordinate system. Traditionally, what you would have available to you is a view which would give you a map view, if you will. Okay, so when you brought an image in, it would rectify it or orthorectify it. When you orthorectify, the map has the geometric integrity, the image has the geometric integrity of a map. But that was your only choice up until 10.3. 10.3, we introduced a new coordinate system called image coordinate system. What that does is it brings the image in, and it still knows about the image to ground and ground to image mapping, but it leaves the image undistorted. So, on my left side, what I have here is an image of Haiti, Port-au-Prince Harbor, and north is up. I can see the coastline as it would appear on a map. That's what you would traditionally get. If I go to the image analysis window and I select a layer, I'm given a choice to focus on that image. When I focus on that image, it will transform it into the image coordinate system as the sensor saw it, and hence I have native geometry of the image, but I can then bring all the rest of my map data in, and it will honor the geometry of the image. So it'll take the roads, map it onto the image. If I have a second image, it'll take that second image and bring it into the first image geometry. So, you want to give a quick demo?
Sure.
Okay.
So how many people actually work with oblique imagery? Have you ever do you ever have problems looking at it because it gets transformed to the ground? Mm-hmm. Doesn't look right? Right? I mean, the image coordinate system is really designed to deal with this. So if you've opened up an image in Envy or ERDAS or any other image-centric application, you'll say it looks different than ArcMap. And ArcMap looks really weird. And well, ArcMap's putting that image on the ground. And ICS was designed so that you don't have to put it on the ground. So conceptually, we tend to talk about it as it's putting a map on an image versus an image on a map. Okay? So it doesn't mean you lose any functionality. It means that the image stays not distorted, and the geographic features transform to the image space. But it's not actually on the ground. Okay? But when you use the tools, the transformations are there to say everything is in the right spot, and if you were to poke and say what's the lat long on that point, it would be accurate. Okay? So the easiest way to do it is to show you. So here I have that image that was in the slide deck, and I don't know if you can really see, but I have some cartography, some geographic features on top of the image, and it's a tank farm. And if you look at it, they don't really look right because they're just harder to interpret because the image is getting distorted because it's highly oblique. Okay? So we have a workflow for that now, and we have a coordinate system to help you deal with that. So what I can do is I can select, again, I'm working with a mosaic, and in that mosaic, I selected my image. And what I can do is I can say, I'm going to add that image directly to the map to work with it in image space. So I can say add selected. So I'm going to say tank farm view. Okay, now I have this image. I can turn off the mosaic and the image will still be there. And I'm going to put my vector data back on top, actually. Okay, so now if I go to the IAW, okay, this is in the image analysis window, we've added something new. If you right-click the image, you can say focus to the image. Okay, now the image goes undistorted. Okay, and the geographic features are still aligned. Okay, they're still there. Now all I have to do is top up it to the sensor. Okay, now if I zoom in, they look right. And I just need to refresh this here. They look right. Okay, so the image is not distorted. It's in the direction the sensor was looking. And the geography is being transformed to the image. Okay, so that's something that's actually been missing from ArcGIS for forever, 40 years. It's there. It got released subtly in 10.3. Do you mean edit?
Well, no, just like if you want to use, say, if you had that form and you had additional polygons.
Yeah. 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 Yeah.
Yep.
Yeah.
Yes.
What if we have a pictometry of it?
A what?
Pictometry.
And they on their side?
So if you have access to the metadata, meaning the position when the image was taken and the attitude, then it'll know what the ground to image mapping is and vice versa. So if you have that, it will work with an oblique image like pictometry.
So the business answer to that is you need the pictometry extension first.
Right.
Because you have to have their extension to even use pictometry images in ArcGIS. If you purchase that and you have that, then it all works. Because it's going to use it's going to use a transform.
Yeah.
Now the difference will be is you still have to use the pictometry measurement tools, not the Esri measurement tools, because that's proprietary as well. So they don't allow measurement on our measurement tools to work on their imagery.
Yeah, there is. Yes.
So as long as you have the rule is if you bought their extension, it should all work.
Let's say I figure all this out. Can I cache it to Thomas?
You want to cache what? One image?
No, yeah. But let's say I go through this transformation, drop it up, this extension, then I want to make a map.
If you are, yes, the ICS works in the server environment. You can make a service out of it. You can cache it. But keep in mind, this coordinate system is specific to that image, which means your other obliques are going to warp all weird to line up with them. So it's not, there's no such thing as a universal coordinate system for all obliques.
Right.
Right? So,
Well, because every image has its own perspective, right?
Has its own perspective. You have different cameras on the plane, right? So if you're trying to create a cache for one image, it's going to work fine. But anything on the outside is going to look funky because of the way it is.
So there was one thing Mike did that's very critical, and that is he selected that one image, he brought it in as out of the Mosaic Dataset, he locked that raster. And you do need to tell ArcMap that that is the one image you want to have for the geometry. So. Yes, there is a help on ICS. Focus on image will also be an important phrase that you'll want to use.
focus on image is probably an easier way to find it. And then if I wanted to go back, right, I can just refocus back on the Mosaic Dataset. And now I'm back.
And there's some blog entries on it as well.
And I can actually get rid of the rotation as well. Right? So then I end up back where I was. So I can select images from Mosaic, focus on it, work in image space, go back to the Mosaic. So I'm using the library to pick one, work with it. Library, pick one, work with it. Yes? No.
Not yet.
So technically the answer is the image coordinate system is in Pro. There's no user experience for it yet. And the reason for that is we are doing a bigger project because Pro, this is very simple because ArcMap has a single view. So what we're doing in Pro is we're going to take this and we're actually going to do more. We're going to say, look, you can select a point on the mosaic and we'll create you all the oblique views by inspecting the mosaic in a multi-view. Right? So like if you want to see all the sides of a building, you don't want to just do it with one view. You're going to want Pro to have one view for each look angle. Yeah. Mm-hmm. So that's part of the Pro plan, which is why it's taking a bit longer because it's a bigger design effort.
Yeah. Okay.
Okay.
Let's go, in the interest of time, let's plow ahead here. So the next thing you, of course, want to do is you want to be able to disseminate all your good work out to your users. The one thing that is worth mentioning about the Mosaic datasets and what's possible with Mosaic datasets is you can produce multiple products out of a Mosaic dataset, hence multiple products, often image service. So in this case, what I'll use is a traditional raster, right, not an image, and talk about elevation data. So I have elevation data. I put it all into a Mosaic dataset, or a better way is I point to it with a Mosaic dataset, and now I can generate that elevation product. But people, of course, don't necessarily only want elevation. They may want to visualize slope, or they may want to visualize hillshades. I can then have a secondary raster function chain attached to that and process these other things out. Similarly with imagery, I might have a Mosaic dataset of Landsat imagery or worldview imagery, but then I would also want to be able to publish out NDVI or other vegetation indices, right? Maybe pan sharpening. I can do all of that against one Mosaic dataset. In the process of developing these things, the Mosaic dataset can feed me metadata. So on a service or direct off the Mosaic dataset, I can see all the metadata associated with things. I can get at raw pixels. I can get at what we refer to as pictures, which means nicely visualized pictures, but not for analysis. I can serve out all the OGC standards of WMS, WCS, KML. Right? All of that's available on an image service. And I've got APIs to look at those, whether they be our REST APIs or if I'm working with them on ArcObjects, etc. And finally, I use this to develop apps, right? If I have ArcMap or Pro, well, that's, of course, a desktop-style app. I can consume those image services. I can actually publish from them as well. But I can also enable web apps, or if I want to go to mobile devices, right, I can consume those image services on my mobile devices as well. So that's what comes along with all of this information model and the technology, functional technology that supports it. Imagery is integral to GIS. I think you'll see a lot more capability rolling out in the near future. Imagery is also readily available, whether it be our services or other people's services. There's a variety of advanced tools you can use. You can treat image collections as single data sets. That's important. So the message here is really spend some time. We've kind of given you a briefing on introduction to the language ArcGIS. So make use of that. Go out and hopefully it'll help understand our documentation and the likes. There is certainly a lot more outside the scope of what we've been talking about available to the partners and the likes. There were some other workshops. Yes, they occurred before this workshop did, but we have recorded these, so you can go back and explore other workshops as well. One of particular note is managing imagery and raster data using Mosaic datasets. That was given on Tuesday and Wednesday. course, the documentation. There's survey forms in the back. You also have an app, which you may or may not have downloaded. If you did download the app, you can do a survey on that as well. I'd encourage you to provide some feedback. You can say nice or nasty things about Mike and I, and we accept all inputs.
Which one? You want the one with the Mosaic Dataset workflow? That one? Yep.
There it is. Thank you.